to use SVCs, TCRs, and TSCs to regulate the voltage of any bus bars. So this is the simulation that we done in the previous video. So we have one grid, one transmission line is 100 kilometer with 0.1, 0.1 ohm reactances in 110 kilovolts. And here we have one transformer. We don't have anything specific, is 100 megavolt ampere, and this one is 100 kilometer, and here we have a load with 50 megawatt. In previous video we used tap changer in this transformer to regulate the voltage. If we make a load flow, you can see here we have 0.95 per unit for voltage, and if we use, for example, tap changer, we can decrease and we can increase the voltage level of the bus bar. But the point is that if we use the tap changer for transformer, we only can change the voltage of the secondary of transformer. We cannot regulate the voltage of the primary of the transformer due to the voltage drop of transmission lines. So we assume that we don't have any tap changer. I put it to 0, another load flow. So you can see here we have 0.96 or 4% voltage drop, and here we have 5% voltage drop. So one of the methods for regulating of the voltage after the tap changer is using reactive power injection units. So here we have in the shunt and filters, we have shunt filter capacitor, or we have SVS. So first we use, for example, one capacitor for connection here. So capacitor injecting the reactive power, and reactive power can increase easily the voltage in any bus bars. So if we double click here, first we should change the rated voltage to 110, and it's 3-phase, and here we can regulate the reactive power value. So for example, I put 40 megavar here, make another load flow, and you can see here the voltage is changed to 0.99. But you should find the value by trying or find the value by calculation of the reactive power compensation. So here we can see now is 0.98. So this is only one capacitor can regulate the voltage easily. Another method is static var systems, or SVS. So here, if you connect the SVS to the bus bar, if we double click, we have TCR and TSC. So TCR is the inductance if you have some increasing the voltage and you want to reduce that, and TSC is the capacitor if you want to increase the voltage level. But if you go in the load flow, here we have the voltage control in the control mode. So if you click OK, and I deactivated the capacitor, even I can delete that. So only we have SVS. If we will make a load flow here, you can see the voltage is returned to 1 per unit. So if I remove this, make a load flow is 0.96. If I connect that, is 1 per unit. So because the reason is that we have a voltage control here, automatically it can control the value is needed for voltage regulation. So here it injected 55.3 megawatt. If you want to put the numbers here by hand, here remember that the value, as we can see here, Q should be less than 0, negative values, and here for inductance it should be positive value. Then you can come back here and control, you can say reactive power control or no control, then you can put the values yourself.